Hello friends, this video on communication systems part 11 is brought to you by examfear.com. No more fear from exam. Let's look at the second factor, that is the effective power radiated by antenna. So if you think of it, how do we find out power radiated by an antenna? For that matter, how do we find out or how do we determine power? So power is nothing but energy per unit time. Right? And what is energy? Energy is nothing but h nu, that is energy is directly proportional to frequency. And what is frequency? It is nothing but c by lambda. So we can say that energy is inversely proportional to lambda, that is wavelength. And we also see that power is equal to energy per unit time. And what is this per unit time? How is time related to wavelength? If you think of a wave like this, you would know how is time related to wavelength. Now, as time increases, your wavelength will also increase. So from this, we can say that power is directly proportional to 1 by lambda square. That is, power is inversely proportional to wavelength. Now, when I consider only the power and the wavelength, what do we see? The power radiated will be more when the lambda is less. Now, when do you say that the transmission is effective, or when we say that the signal transmission was successful and effective? So, for effective transmission, more power should be radiated. So we say that for effective transmission of signals, power should be more. Now if I want the power to be more, then the lambda, that is the wavelength, should be less. And if the wavelength is less, the frequency is gonna be more. Therefore, high frequency is needed for effective transmission, right? Because for effective transmission, power radiation should be more. Power is more when the wavelength is less. Wavelength is less when the frequency is more. So even this says that high frequency signals are desirable. So the second vote also comes in favor of modulation, right? Okay, so let us now look at the third factor, which says mixing of signals from different transmitters. So what mixing is it talking about? Let's forget about transmitters. Let us look at an example and try to understand the concept behind this factor. Let us suppose you are sitting in a conference room or a meeting room where quite a number of people are sitting, right? Now, there is a topic on which everyone is discussing, correct? Now, let us suppose everyone has his own viewpoint regarding the topic and everybody starts speaking. Now, let us suppose that everybody starts speaking at the same time and they are talking simultaneously. So you just see there are so many people inside the room, maybe some 15 people or 20 people, and all of them are talking simultaneously. Now, will any of them be able to understand what each of them is speaking? No, right? Because since all are speaking, their voices are getting mixed up together. So the result is that none of them are understandable, right? Their voices are mixing up. Whatever they are telling, everything is getting messed up. So you are not able to understand anything. So there is no use if all the persons speak together. Similarly, let us suppose if you have a road where there are too many vehicles coming at the same time. There are different routes, different vehicles coming and joining the same route. What will happen? It will create a chaos. Since too many vehicles are there, there will be traffic jam. Vehicles will not be able to proceed. Why? Here also, mixing up of vehicles. So, since there is just one route for all the vehicles, so things are getting messed up. Now, what is a solution to these kind of problems. Now, if you look at the first problem, where the problem arises because all of them speak at the same time. So, a possible solution could be if each of them is given a time slot. Let us suppose there are 10 people inside the room and we say that, okay, each of you will be given 5 minutes to speak on this topic or to express your views. In that case, what would happen? The first 5 minutes comes to the first person, the next 5 minutes for the second one, the next 5 minutes for the third one, and so on. So what would happen? During one time slot, there will be only one person who would be speaking, and that is why we will be able to interpret what he is talking, right? Similarly, if we look at the problem of this traffic, now instead of having one route, if we make an alternate route, what would happen? The number of cars on each route will get reduced, because let us suppose earlier if there were 50 cars on the same route, now if we have two alternatives, at least some 20 cars will go on one route, some 30 cars will go on the other route. So the mixing up will be lesser because people will be following their own routes. So that will not create that much of chaos, right? So you understand the concept of mixing of signals. So on a similar note, we will talk about mixing of signals from different transmitters. Now let us suppose when there are many transmitters which are transmitting signals at the same time, what might happen? The signals might get mixed up with each other. Now once the signals get mixed up with each other, there is no way that we can distinguish them. Let us suppose, because the communication system, it is happening it is happening at so many different places at the same time. For example, right now let us suppose I call up my mom and I'm speaking with my mom. So what is this? This is the communication system. There is a transmitter involved, there is a receiver involved, right? And the communication is going on between me and my mom. Similarly, maybe at the same time, you are calling your friend. So you are also talking to your friend. So what is going to ensure that my mom is able to hear what I am speaking and I am able to hear what my mom is speaking, and not that I am hearing your voice or I am hearing your friend's voice. So what will ensure that the correct recipient gets the correct message? Because since everything is happening at the same time, so the signals might get mixed up with each other. There are good number of chances, right? So what is a solution to that? So the solution in this case is to translate the original low frequency signal into a high frequency wave such that the translated signal continues to possess the information contained in the original signal. Right? So it is very much important to retain the information. Like if I am speaking with my mom, I want my mom to hear what I am speaking. So my information should be retained by the communication system. Right? So this is what is shown here. Similarly, if you are talking to your friend, we do not want each of our information to get mixed up with each other. Right? I want my information to be retained. You want your information to be retained and reach only your friend. So in order to ensure that, what do? We translate the low frequency signal into a high frequency wave. Now you might be wondering, how will that make a difference? Even if I change the frequency, how will that make a difference? Now let me talk about, now in previous slide I talked about time slots, right? We were giving different time slots to each person. So here I will talk about frequency slots, because here I am talking about the signals. Right? Now let us suppose if I am talking about a low frequency signal. So if I am talking about the low frequency message signal, and if I say that I give different frequency slots to each signal, so what would be the slots like? Because since I am talking about low frequency signal, so in case of low frequency signal, the frequency slots would be something like 50 hertz, 60 hertz, 70 hertz, 80 hertz. So we will be giving small frequency slots as well, right? Because we are right now talking about low frequency signal. Now, if I convert this low frequency signal into a high frequency signal, then what kind of frequency slots I will be talking about? Maybe I will be talking about 50,000 hertz, 60,000 hertz, 70,000 hertz, and so on. Now, if you compare this frequency slot and this frequency slot, what do you feel? A signal with 50 hertz frequency and a signal with 60 hertz frequency. So, the difference between them is very less, right? So, there are still chances of these two signals getting mixed up. But if you compare a signal of 50,000 hertz and 60,000 hertz, the difference between the two signals is 10,000 hertz, which is a huge gap. So here in this case, the gap between the two signals is very less. But here, the gap between the two signals is huge. So the chances of mixing up is less. So that is the advantage of converting a low frequency signal into a higher frequency signal, because in higher frequencies, the frequency slots which will be given to each signal, the difference between them will be huge, because of which the mixing of the signals can be avoided. So now the question is, how do we do this translation? How do we translate a low frequency signal into a high frequency signal? Now this translation of low frequency signal to high frequency signal is done by the process of modulation. So even the third vote comes in favor of modulation, right? So we saw that all the factors which affect the transmission of signal over large distances wants high frequency waves, and the process of modulation does that. Modulation creates high frequency waves. It translates the low frequency wave into a higher frequency wave. Right? Thank you. Please visit www.examfear.com to watch more videos, attempt free online test, get free study material, find tutors and mentors. Thank you once again.